Right now, without anyone noticing, a lonely machine is floating nearly 1 million miles away from Earth. It never sleeps. It never blinks. Day after day, it keeps its enormous golden mirror fixed on a single, almost invisible point of light in the constellation Leo. If you looked into the night sky yourself, you would never find it. Even many of Earth's largest telescopes struggle to see something so faint. Yet, for more than 3 years, that tiny point of light has become the center of one of humanity's greatest investigations. But before we continue this incredible journey, take just a moment to subscribe to the channel. We're working toward our first 1,000 subscribers, and your support helps us bring you more cinematic stories about the greatest mysteries of space, history, and science. Now, let's continue, because hidden inside that distant speck is a world unlike anything we have ever seen. Because hidden inside that distant speck is a world unlike anything we have ever seen. A planet lying 124 light-years from Earth. A planet warm enough that liquid water could exist. A planet that may be covered by one endless ocean stretching across its entire surface. And in 2025, scientists noticed something drifting through its atmosphere that changed everything. On Earth, that same chemical is associated with life. Not rocks, not volcanoes, not lightning. Life. When the first analysis appeared, even the scientists struggled to describe what they were seeing. The lead researcher simply called the moment profound. Within hours, newspapers, television stations, and websites around the world were asking the same breathtaking question. Had humanity finally discovered life beyond Earth? For a few days, it felt as though history had already been written. But history was only beginning. Because after the cameras disappeared and the headlines faded, another story quietly unfolded. A far stranger story. A story filled with arguments, uncertainty, competing ideas, and discoveries that almost nobody outside the scientific community ever heard about. And hidden beneath all of that noise was something even more remarkable. Not proof of alien life, something far more valuable. The best opportunity humanity has ever had to answer the oldest question our species has ever asked. Are we alone? By the time this story ends, you'll understand exactly what the James Webb Space Telescope actually discovered, what it didn't discover, and why the next few years may completely change our understanding of life in the universe. But to understand how we reached this moment, we have to travel back to a dying spacecraft. The year was 2015. By then, NASA's Kepler Space Telescope was already living on borrowed time. Years earlier, mechanical failures had crippled its original mission. Most spacecraft would have been retired. Kepler wasn't. NASA found a way to keep it alive under a new mission called K2. It wasn't perfect anymore, but it still had one job: watch thousands of distant stars, wait, and search for the smallest flicker imaginable. Not an explosion, not a flash, just the tiny dip in brightness that happens when a planet quietly crosses in front of its star. The change is almost impossible to notice. Imagine standing miles away from a single streetlight, then trying to detect the exact moment a tiny moth flies across the bulb. That is the level of precision Kepler was attempting. Most of the time, the telescope saw nothing extraordinary, just endless streams of numbers, thousands of stars, thousands of planets, thousands of ordinary discoveries. Then one day, buried inside that mountain of data, astronomers noticed something circling a small, dim red star known as K2-18. They gave the planet a simple name: K2-18b. At the time, nobody celebrated. There were no television interviews, no breaking news banners, no worldwide excitement. It was simply another planet added to an already enormous catalog, just another distant world. Or so everyone believed. Because hidden inside that ordinary discovery were three extraordinary details, three facts that would eventually place K2-18b at the center of one of the biggest scientific debates of the 21st century. The first surprise was its size. K2-18b weighs roughly 8.5 times more than Earth and is about 2.5 times wider. That makes it something astronomers call a sub-Neptune. Curiously, our own solar system has nothing like it. We have small rocky planets like Earth and Mars. We have giant worlds like Jupiter and Neptune, but nothing in between. The universe, however, seems to love planets exactly like K2-18b. They are everywhere, yet we still know remarkably little about them. The second surprise was where the planet lived. Every 33 days, it completes one orbit around its tiny red dwarf star. If that same orbit surrounded our Sun, the planet would be scorching hot. But K2-18 isn't our Sun. It is much smaller, much cooler, much dimmer. That changes everything. Instead of being roasted, K2-18b sits inside one of the most important regions astronomers know, the habitable zone, the place where temperatures may allow liquid water to exist, the famous Goldilocks zone. Not too hot, not too cold, just right. And then came the third detail, the one that transformed K2-18b from another distant world into one of the most important planets ever discovered. From Earth's exact position in space, K2-18b passes directly in front of its star. A perfect cosmic alignment, an accident of geometry, but one with extraordinary consequences, because every time the planet crosses its star, a tiny amount of starlight slips through its atmosphere before continuing its 124 light-year journey toward Earth. And hidden inside that ancient light is the story of another world's sky. Imagine a single beam of light beginning its journey from a small red star in the constellation Leo around the year 1902. At that moment, no airplanes crossed the sky. No one had walked on the moon. Your great-grandparents may not even have been born yet. That tiny stream of light left its star and traveled across 124 light-years of empty space. For almost its entire journey, nothing disturbed it. Then, for just a few brief moments, it passed through the thin atmosphere surrounding a distant planet called K2-18b. As it slipped through that alien sky, something extraordinary happened. The gases floating high above the planet quietly removed tiny pieces of the light. Every molecule, whether methane, carbon dioxide, water vapor, or something else, absorbed its own unique pattern of wavelengths, leaving behind an invisible fingerprint. Then, the light continued its journey. For more than a century, it raced through the darkness until it finally arrived at a telescope built by human hands. Hidden inside that ancient beam, written like a secret message in a language made entirely of shadows, was the chemical recipe of another world's atmosphere. That sounds like science fiction. It isn't. It is something humanity can actually measure. The first serious attempt came in 2019. The Hubble Space Telescope turned its attention toward K2-18b, hoping to read the faint fingerprints hidden inside its atmosphere. When the data arrived, astronomers believed they had found the signature of water vapor. It was an extraordinary moment. For the first time in history, water had been reported in the atmosphere of a planet orbiting inside the habitable zone beyond our solar system. Almost overnight, K2-18b changed from an obscure catalog entry into one of the most fascinating planets ever discovered. But excitement quickly gave way to caution. Hubble was one of the greatest telescopes ever built, yet it had never been designed for measurements this delicate. Its instruments could observe only a small portion of the light reaching Earth. Some researchers looked at the same data and reached a different conclusion. Perhaps it wasn't water after all. Perhaps the signal belonged to methane, The evidence simply wasn't sharp enough to settle the argument. Once again, the little planet in Leo kept its greatest secrets hidden. If humanity wanted clearer answers, it would need a far more powerful telescope. That telescope left Earth on Christmas morning in December 2021. Perched atop a rocket was the James Webb Space Telescope, the most ambitious scientific instrument humanity had ever attempted to build. Its enormous gold-coated mirror, stretching more than 6 meters across, had been folded like a piece of intricate origami, just to fit inside the launch vehicle. Once it reached deep space, nearly 1 million miles from Earth, the mirror unfolded perfectly. Behind it opened a giant sun shield, roughly the size of a tennis court, protecting the telescope from the sun and cooling its instruments to temperatures colder than anything inside an ordinary freezer. The mission had taken roughly 25 years to build. It had cost around $10 billion, and perhaps most astonishing of all, hundreds of separate deployment steps had to work perfectly without a single opportunity for astronauts to repair anything. One mistake would have ended the mission forever. None came. Every deployment succeeded. Humanity's most powerful eye was finally open. In 2023, astronomers led by Professor Niku Madhusudan at the University of Cambridge turned James Webb toward K2-18b. For years, the planet had remained hidden behind uncertainty. Now, the fog finally began to lift. When the results were published in September 2023, they immediately caught the attention of astronomers around the world. Methane was there. Clearly, carbon dioxide was there as well. For the first time in history, carbon-bearing molecules had been confidently detected in the atmosphere of a planet located inside the habitable zone. Yet one of the most important discoveries was not something Webb detected. It was something it almost completely failed to find. Ammonia. To planetary scientists, it was an enormous clue. According to atmospheric chemistry, if K2-18b were simply a giant ball of gas from top to bottom, ammonia should have been floating high in its atmosphere, where Webb could easily detect it. Instead, it appeared to be disappearing. Something beneath the atmosphere seemed to be quietly removing it. One explanation stood out above the rest. Beneath that hydrogen-rich sky, there could be an enormous global ocean of liquid water silently absorbing ammonia from the atmosphere above. If that idea were correct, K2-18b belonged to an entirely new class of worlds. Astronomers call them Hycean planets. The name combines two words, hydrogen and ocean. Imagine a planet with no continents, no beaches, no islands, no mountains breaking the horizon, only water, an endless ocean stretching farther than the eye could ever see, beneath an orange sky lit by a swollen red star. There would be nowhere to stand, only water extending in every direction. The red dwarf above would cast the planet in permanent amber twilight. Gravity would pull on your body with more than twice the force you feel on Earth. And below you, instead of oceans only a few miles deep, water could descend for unimaginable distances into crushing darkness and pressures beyond anything human technology has ever explored. If life existed in such a place, it would have evolved under conditions unlike anything found anywhere on Earth. That possibility changed more than our understanding of one distant planet. It changed the mathematics of the galaxy itself. Sub-Neptune planets like K2-18b are not unusual. In fact, they are the most common type of planet known to exist. Our own solar system simply never formed one. If even a fraction of these worlds contain liquid water beneath hydrogen-rich atmospheres, then the number of potentially habitable planets does not merely increase. It explodes. Instead of searching for a handful of Earth-like worlds scattered across the Milky Way, astronomers may have billions of ocean planets waiting to be explored. And hidden deep within that same 2023 dataset was another mystery, a whisper, so faint that many scientists almost overlooked it. A signal that would soon ignite one of the biggest scientific debates of the decade. Hidden inside that same 2023 dataset was another mystery. At first, it was almost invisible, not a discovery, not even convincing evidence, just a whisper. A faint and uncertain hint of a molecule called dimethyl sulfide. The signal was incredibly weak, far too weak for any responsible scientist to declare a discovery. Most people barely noticed it. Many researchers quietly set it aside. But the Cambridge team could not, because they knew something that made this tiny signal impossible to ignore. Here on Earth, dimethyl sulfide has a remarkable origin. It is not normally created by volcanoes. It does not come from lightning. It is not produced by ordinary rocks or by simple ocean chemistry. Instead, almost every molecule of dimethyl sulfide in Earth's atmosphere begins its life inside living organisms, tiny microscopic plankton drifting through our oceans continuously release it into the air. That familiar scent you notice while standing beside the sea. Part of what you're smelling is dimethyl sulfide. In a sense, it is the breath of Earth's oceans. So the possibility, however faint, demanded another look. The team requested additional observing time on the James Webb Space Telescope. This time they used a completely different instrument, one designed to study another range of infrared wavelengths, hoping to see whether the mysterious signal would appear again. Then they waited. Once more, K218b drifted across the face of its star. Once more, ancient starlight passed through its atmosphere. And once more, James Webb captured every possible clue. When the new results arrived in April 2025, they spread across the world almost instantly. The new observations revealed signatures consistent with dimethyl sulfide, or its close chemical relative, dimethyl disulfide. The statistical confidence had reached 3 sigma. Even more astonishing was the estimated abundance. If the interpretation proved correct, the concentration could be thousands of times greater than anything found in Earth's atmosphere. The implications were staggering. If those molecules truly came from biology, then the ocean covering K218b would not merely contain life. It could be overflowing with it. An entire planet whose seas might support biological activity on a scale beyond anything Earth's oceans have ever produced. The Cambridge researchers described it as the strongest hint of possible life beyond our solar system ever detected. Professor Niku Madhusudan, known for his careful and cautious approach, resisted dramatic conclusions. Instead, he simply said that, however one interpreted the evidence, humanity was witnessing unfamiliar chemical processes on a potentially habitable world. That was enough. Within hours, newspapers across the globe carried the story. Television programs debated it. Social media exploded. For several remarkable days during the spring of 2025, millions of people seriously wondered whether humanity had finally found evidence that we were not alone. But every great scientific story eventually reaches the moment where excitement gives way to evidence. This was that moment, because understanding a 3 sigma result is the key to understanding everything that followed. A confidence level of 3 sigma means the probability that the signal is caused purely by random chance is roughly 0.3%. To most people, that sounds almost certain. After all, it corresponds to about 99.7% confidence. But astronomers have learned, often painfully, that the universe enjoys producing convincing illusions. Signals with 3 sigma confidence have appeared before. Many disappeared when better observations became available. That is why modern physics and astronomy demand something far stronger. A discovery is generally accepted only after reaching 5 sigma, reducing the odds of a statistical fluke to roughly 1 chance in 3.5 million. The Cambridge team understood this perfectly. They never claimed victory. Instead, they estimated that only 16 to 24 additional hours of James Webb observations might be enough either to elevate the signal to 5 sigma or eliminate it completely. The finish line suddenly seemed close. Then science began doing exactly what science is supposed to do. Before anyone could celebrate, research groups across the world downloaded the publicly available Webb observations and started examining every detail for themselves. No one was trying to destroy the discovery. Quite the opposite. Extraordinary claims deserve extraordinary scrutiny. If the evidence survived, it would become even stronger. If it failed, humanity would avoid fooling itself. Very quickly, difficult questions began to appear. One independent research team processed the same observations using different, but scientifically acceptable, statistical techniques. Their conclusion was unexpected. The dimethyl sulfide signal weakened dramatically. Across most versions of their analysis, it disappeared entirely. Another group expanded the investigation even further. Instead of testing only one possible molecule, they compared the observations against a database containing approximately 650 different chemical compounds. Their results raised another problem. Several completely ordinary molecules fit the observations just as well. Because James Webb was observing K218b at the edge of its current capabilities, the spectral fingerprints of different molecules overlapped. Dimethyl sulfide and something as chemically ordinary as ethane could produce nearly identical patterns. When scientists combined every available observation from every James Webb instrument, the conclusion became more cautious. There simply was not enough evidence to claim a biological signature. Then the story took another unexpected turn. Scientists studying data from the European Space Agency's Rosetta mission discovered dimethyl sulfide on a comet, a frozen object made of ice and dust, completely lifeless. Soon afterward, astronomers identified the same molecule drifting inside enormous clouds of gas between the stars. Laboratory experiments added one final piece. Under conditions similar to those found on exoplanets, dimethyl sulfide could form through ordinary chemistry alone. No living organisms required. Almost overnight, the molecule many people had celebrated as a smoking gun for alien life gained an entirely non-biological explanation. By the end of 2025, most astronomers agreed on a careful conclusion. K218b had not yet met the standard of evidence required to claim life beyond Earth. For many people, that sounded disappointing. Some even called the episode an embarrassment. But the story was far from over, because while the world argued about one uncertain molecule, James Webb kept watching, and what it confirmed next turned out to be even more important. Later in 2025, another team, led by Dr. Renyu Hu at NASA's Jet Propulsion Laboratory, observed K218b during 4 additional transits, measuring its atmosphere with greater precision than ever before. This time, several conclusions emerged with remarkable clarity. Methane was unquestionably present. Carbon dioxide was unquestionably present. Those discoveries survived every independent test. Then came the most surprising result of all. When researchers modeled every observation together, one explanation consistently matched the data. K218b appeared to be a genuine water world, not a rocky Earth, not a miniature gas giant, but a planet whose interior could contain extraordinary amounts of water.